Hello everyone, hope you're doing well. Today I'm going to talk about a project I completed a year or so ago to charge my Ryobi electric tractor with a solar panel. I'm going to go through the parts, materials, and steps to build something on your own. So I obviously talk about this, supported tractors, the buck boosts or the boost converter setup, the voltages, the wiring, and the materials required for this project. Looking at it right here, the 3 different tractors at least that Ryobi makes, 30-inch deck, 32-inch deck, 38-inch deck, and a 42-inch zero-turn tractor, all of which run on 4 lead-acid batteries or 48-volt tractors. I'm going to go through basically the input side on the solar panels, look at maybe some alternate DC systems, and talk about the power requirements for charging this in the pin setup. So a boost converter will allow you to take whatever input you get from your solar panel or your solar panel charge controller. Either is okay. What you're looking for on the input side is somewhere between 12 and 50 volts. You see written on the particular boost converter is the input range accepted to it. Actually, it's over here, 12 to 60 volts. Without a charge controller, you won't have the drawdown of the charge controller, but you will be subject to whatever the current solar conditions are, and you won't be pulling from a battery bank, which I presume you'll have on your solar panel setup. Output voltages, looking at 2 numbers. Charging the batteries will be based on a charge number, or 2.45 volts per cell, or 14.7 volts per 4 batteries, so 58.8 volts. A float voltage of around 55.2. So looking for a number somewhere in between, so that without harming the batteries, you can leave them on a voltage, whether they're charging or floating. So I happen to pick an optimal voltage for my setup of 56 volts, so that's what I've recommended. It's been keeping the batteries perfect, and it charges within a couple days on a 200-watt solar panel for me. So this is the input side of the equation. Now we'll go through how to get this power into the tractor itself. All these tractors have a 3-pin connector. The bottom 2 pins are the ones we're concerned with. The left one is positive and the right one is negative. You can confirm this with your voltmeter. Obviously set it to something over 12 volts so you don't damage that. The connectors on the side of the tractor will be 2 3.5 millimeter bullet connectors. And if you solder those to a wire, the other end of it, use a barrel connector, DC barrel connector like you typically find on old school 12-volt devices, maybe an alarm clock or something like that. But of course we'll be running 55 volts through it, 56 volts through it. The gauge of the wire isn't important because we'll be running high voltage, it's low amperage, so the gauge of the wire is less important for that, certainly since it's low amperage. So I'll go through the specific, in the comments, in the description at the bottom, I have links to these parts as well. So last slide, conclusion, specifically materials. You need an 80-volt 80-volt boost converter. So it's not necessarily a buck converter because we're not down. So it's an 80-volt boost converter. We're boosting somewhere from 12 to 24 volts to this higher one. A 60 volt or 50 volt is probably not sufficient. I've found that the 80 volt boost converter works the best. 2 3.5 millimeter bullet connectors for positive and negative going into the tractor, and then a male-female pair of barrel connectors so you can quick release when you pull the tractor off the charger, of course. And then just some miscellaneous supplies, of course, a voltmeter for tuning the boost converter. As you see in the picture here, there are 2 adjusters, each labeled for amps and volts. The voltage is the one we'd critically set to 55 volts. The amperage be based on the power of your source, and this of course will affect how long it takes for the tractor to charge after running it. I'm recommending putting it at the lowest setting you can get away with. Give the tractor a couple days to charge. I don't know how often you cut your grass. For me, it's once or twice. I was gonna say once a week, or less often. So I've been very happy with the setup. And then we talked about the gauge wiring. I trust you have some of that around. And then depending on how you're going to set up the boost supply, put it on the wall out of the way or up under part of your garage. Perhaps a case to keep the dust, but I'd recommend something that keeps some cool air coming in and out. I've not noticed any overheating on mine, but I have mine up and out in my garage. So let me know in the comments if you have any questions, or contact me directly. I'm happy to help anyone out who's building one of these. I've been very happy with my solution, and it makes a green tractor even greener. So thank you very much.